The Hillsborough Caldera. It's a pin on the map between Hillsborough, Chapel Hill, and Durham, North Carolina. 3 all-American growing towns on the East Coast, seemingly nowhere near a volcano. To understand what the caldera is, we will need to go back in time, way back. The Earth 600 million years ago was vastly different than it is today. Living organisms were soft-bodied and lived in the ocean. The concept of predator and prey didn't exist yet. Land was rock, dust, and otherwise barren. Root systems for plants and trees wouldn't evolve for another 200 million years. Tectonic and volcanic activity wasn't much different 600 million years ago as it is today. This footage was captured from the recently discovered West Mata volcano in the South Pacific near Samoa. Just like 600 million years ago, undersea volcanoes create new land as ejections of tephra, ash, and lava build up on the seafloor. This is the process that created the Hillsborough Caldera and the volcanic island chain called Carolinia that it was a part of. In this graphic, we can see the 3 distinct phases that led to the formation of the Carolinia Volcanic Island Chain. In Phase 1, magma intrudes the Earth's crust. In Phase 2, the growing magma chamber causes bulging and erosion of rock layers. Lava domes form and tephra is ejected. In Phase 3, volcanic islands have formed. The original magma chambers explode, releasing tons of debris. The magma chamber collapses, forming the caldera. The Hillsborough Caldera is resurgent. The magma chamber refills and the process begins all over again. Recent examples of these structures are still visible, such as the Occoneechee Caldera and the Aleutian Island. The Aleutian Islands themselves are a volcanic island chain, similar to ancient Carolinia. The rocks of the Hillsborough Caldera and Carolinia were changed about 400 million years ago when Carolinia collided with ancient North America. 150 million years after that, ancient Africa collided into ancient North America, forming Pangaea. During its active phase, the caldera erupted, collapsed, and reformed for millions of years. Its resurgence, along with subsequent deformations from tectonic events, are evidenced in its oval shape. But if we wanted to find evidence of this violent past, where would we look? Walking up to the base of Occoneechee Mountain's quarry face, you are immediately confronted by the sheer scale of the landscape. There are massive metavolcanic boulders which have detached from the heights above. These rocks, scarred by lichen and deep iron staining, serve as raw physical evidence of the mountain's ongoing erosion. Standing at the summit of Occoneechee Mountain, looking out at Hillsborough from above and sitting among the metavolcanic rocks, you can get a true sense of just how massive the caldera was. As we move from the heights of Occoneechee Mountain down to Fuse Ford, the landscape shifts from ancient weathered peaks to the active work of the river itself. Here the Eno River cuts through the very foundation of the Carolina terrane, a jagged, resilient bedrock formed by volcanic fury over 600 million years ago. These moss-covered outcrops are not just static scenery. They are the silent anchors of the river's past. The Eno River Quarry is a unique intersection between the Eno River and Rhodes Creek. It exposes a diverse array of rock types that would otherwise remain hidden beneath layers of the soil. By standing at this junction, we get a front row seat to the collision of two distinct geological stories: the dark, massive metavolcanic basement rocks, and also the lighter sedimentary fragments that have been weathered, rounded, and deposited by the shifting waters of these intersecting waterways. If you plan on coming here, I highly suggest a geological adventure along the Eno River. I'll provide a link to that in the description. This metavolcanic tuff, or mafic metamorphic, by just looking at this stone, you can see that it's not too far removed from its volcanic origins. The rock was very heavy, almost like the weight of history was in your hand. This broken piece of metavolcanic tuff gives us a good example of what the rock actually looks like inside. The dark fine-grained material inside is consistent with metavolcanic. Evidence of the Piedmont's volcanic past is all around, if you know where to look. Be sure to check out the description for additional resources.